Welcome to the video. In this video, we will see how we can use Llama 3.1 model using Python. There are three different versions: 8 billion, 70 billion, 405 billion. What billion stands for? So, in neural network architecture, whatever number of neurons, weights, and the biases we have, that total count it called billion. I mean the params. So that stands this billion. Now, the first way to download the Llama 3.1 model is going to the Meta website and click on this download button, fill up this small form, and then click on the next button. So, basically, the email you are going to put where you are going to get this particular model. Now, the second option, we can go to the Hugging Face website and search for this particular model, the 3.18 billion instruct model. What instruct means, basically it's a fine-tuned version on 8 billion Llama 3.1 model. So you can sign up or create. If you have already signed up, you can log in. Let me log in here. So it shows that you have granted access to this model already. In your case, you will get one small form, first name, last name, some basic organization details, anything, and then you are good to go to grant the access of this model. Within 2 or 3 hours, they will provide the access. Now let's look at the basics of this Llama 3.1 model. It supports multilingual test. It can generate the codes as well. Now the context length is very important. It's a 128K. So 1.28 lakh is total number of tokens it can support. Combined, it should be 128K. So let's suppose the input length is 28,000. Then the output, the maximum it can go is to 1 lakh. So it is very huge. In normal world, that kind of requirement is not there, but it is good to have such kind of complex model. Now the total count is 15 trillion plus total token count. Knowledge cutoff, till what year of training data is it got trained. So December 2023 is the one. Till that it got trained. The trained data usually have a lot of books, a lot of blogs, general information from the Wikipedia, all those articles be included in this training this LLM models. Now this is the basics. Now once you get the access of this model, you need a token from the Hugging Face to use this particular model. So you go to the settings, you go to the access tokens. So I have already created, but you can create new token, put any name, ask for the read access, and then search for that repo. So it will come for you if once you grant the access. Click on this Meta Llama 3.1 and click on this create token. Now you can copy this key here. One only one time you will get this prompt. So you can copy and save it somewhere. Click on the done. Okay, now it is created for you. So let's understand the code as well. So you can see this is the Google Colab where I'm like doing this code, but it has some limitation in terms of GPU. So it will provide 15 GB of GPU for some time. I guess the 1 hour or 2 hours is the total number of time it will for you in a day. Now, initially I downloaded three libraries: Transformer, Bits and Bytes, Accelerate. Transformers is already in Google Colab, but I upgraded it because Llama 3.1 requires the latest Transformers library. After that, you will put that token, which is faced by the Hugging Face, and log in using your credentials. Credentials is only the thing is the token. After that, you just get the model ID from the Hugging Face. This is the model ID, so that it goes in the exact place in the Hugging Face app and download it. From the transformers, we use this class called auto model for causal LM. So The job is to do the text generation, right? So causal LM is for the decoder part. So in the transformer we have two things: encoder and decoder. Decoder is for the text generation, encoder is for the encoding the text. The model mostly lies into the section is BERT. For decoder, mostly LLM models, which is preferred for the text generation. And then tasks like translations and NERP need encoder and decoder both. So one of the examples is Google Flan T5 model, which is having both things, encoder and decoder. So for this purpose, we are using this class, and then the method called from pretrain. We just use that particular model ID. We pass the model ID, then device map. It's auto. So based on the availability, it will go either GPU or CPU. So GPU is there, so it will go to the GPU and do the computation. Now with the Llama 3.1, there is a concept for any LLM model. There is a concept called quantization. By default, it is running in 32-bit, but you can reduce the weights, the size of the weights matrix, and level up to 16-bit, 8-bit, 4-bit, so that it will take less GPU memory. So if you run into the 32-bit, it will take essentially 32 or 34 GB of GPU. I've not tried it, but it will be higher. You cannot run in this Google Colab because it has some limitation in terms of GPU size, right? So by default, I put into the 16-bit, but I will show you the step. You can make it up to 4-bit as well. So there is a configuration for that. We require bits and bytes library which I installed earlier. It's imported from the class transformer, but it is that library is required. So from the transformers, you use a class called bits and bytes config, where you will provide those configurations. Like load in 4-bit needs to be true, so that it will run into the 4-bit, and it will go into the quantization config argument of this from pretrain method. Now you can clearly see it lowers down to the 5.7 GB of GPU memory instead of 14 to 15 GB, which is required for the 16-bit, right? So via this way, you can reduce the size of the code which is running inside on top of GPU, right? Once you run this, it will download the model. You can see the size. It's 16-17 GB of model size. It stores into the model class, model object. Now this model object is required for the to create the transformer pipeline. But there is one other thing which is required, that is tokenizer. So in the transformer there is a class called auto tokenizer. From that we again using from pretrained method and pass the same model ID. It will give me the tokenizer object. Now these three things will be passed into the transformer pipeline method. The task which we want to perform is the text generation, the model which we already initialized, and the tokenizer which is here. Once pipeline object is created, you can execute your runtime query. So in order to execute the runtime query, we'll pass two instructions to the LLM. First is the system query, the second is user query, which will be changed in during the runtime. Now the system in system level, I'm defining LLM as a programming assistant. So for the particular task, you can assign any role to the LLM model. That is essentially required because what domain you want to, what for which domain you want to use your LLM model. Based on that, you need to assign some role to the LLM model. Now, in this case, LLM model is Llama 3.1. The role of the user is to ask any query based on the role of LLM. So I'm asking query called write a code to add two numbers in Python. Now this messages is a primarily list and having two dictionaries. This passed to the pipeline method, and here we'll have the max new tokens, which is 256. It can be anything. It can based on the task. Let's suppose you have the task which requires a lot of text generation, so you can make it 512, 1024, 2056, anything. But there is a cost of that as well. So if you like put higher number of max new tokens, it will take time to process it. So essentially you will not have a good throughput. So based on the task you have, just assign that thing. I'm defining 256 for the demo purpose. Now once I execute this, I will get the outputs. So see what is in the outputs. We have the list actually. In the list we have dictionary, which is having key called generated text. So from that outputs I am getting zero index. From the zero index, generated text is the key. From that we have the, again we have the list, right? From that list I am like extracting the last one. So minus one is my the last dictionary. I'm just extracting the key called content on that, which is this. So it's a simple code snippet that takes two numbers as input from the user and adds them together. We have one method called add numbers. We are taking two inputs from the two numbers from the user and call this method called add number. And finally we are printing those results as well. So you can see it's very clever actually. It's very powerful. In some some scenarios it beats GPT-4o as well. So I would highly recommend you to try this model. And yeah, thank you so much.